Hey guys, the objective of this video is to look at different failure types, which are active and passive. We're going to be looking at the analysis types, which are total and effective stress, and then we're going to be looking at how we actually solve the problems. I'm just going to be showing you a general method. So what are we talking about? We're talking about earth pressures, the pressure that the earth puts on structures, and we're mainly looking at retaining walls. So there's two types of failures that can occur. We can have an active failure on a retaining wall, and we can have a passive failure. So what do these mean? So an active failure is when the soil falls on the wall. So the wall isn't providing enough strength. So we have a profile of soil, and the soil will cause the wall to fail. So the pressure of the soil will fall on the wall. So active failure, soil falls on wall, and we can find the stress that the soil is putting on the wall by this formula. Sigma H min equals sigma V minus 2C square root of n subscript phi on top of n subscript phi. And we know n subscript phi is equal to 1 plus sine phi on 1 minus sine phi. So we know that from the previous series of videos. So that's an active failure. So as you can see, sigma V is a vertical stress, so it is converting a vertical stress into a horizontal stress. That's what this formula is doing. That is for an active failure when the soil falls on the wall. A passive failure is the opposite. So a passive failure is when the wall falls on the soil because the soil isn't providing enough strength. So we have the wall falling on the soil. So our wall I'm putting in black. So the wall is falling on the soil. So wall falls on soil. And the formula we're going to be using for this is sigma H max equals n subscript phi sigma V plus 2c square root n phi, where n phi similarly is 1 plus sine phi and 1 minus sine phi. As you can see, this formula also converts a vertical stress, so sigma V, into a horizontal stress, sigma H. So our aim for all these problems is to find this sigma H, and we can also find the stress per meter, the force per meter if we want to, but we'll see that in later videos. So those are the two types of failure, active and passive. You just have to know those two formulas. So the question will say it's an active failure or a passive failure. It just tells you which formula to use to get from vertical to horizontal stress. The second thing we need to look at is the types of failures. So you can get two types, the types of analysis. So the first type of analysis is a total stress analysis. So we've seen that before. So total stress analysis, we're just going to be using that for undrained clays. And we're obviously going to be using the properties phi u, so phi undrained, and cu, c undrained. And this of course is only in the immediate short term because it's undrained. So short term, total stress, undrained clay. So you can only use this on undrained clays. The other analysis we can do is an effective stress analysis. So effective stress analysis, and we can use this in the short term and the long term. So we've seen this many times before, where we know we can only use a total stress in the short term, but we know we can use an effective stress short and long term. For the short term, we can use it only on sands, and for the long term, we're going to be using it on sands and clays. And the reason we use an effective stress in the short term is because a sand, it will drain very quickly compared to a clay. A clay takes time to drain, it will be undrained, whereas even a sand in the short term, it's undrained. It's said to be undrained because of its permeability. The pore water pressure is going to escape quickly. So the short terms, obviously for an effective stress, we need to know U, which is the pore water pressure, because we know that sigma V equals sigma V dash sigma V dash plus U. So we obviously need to know U to get from total stress to effective stress. So we need to know U, which is the pore water pressure. And in the short term, the pore water pressure will be easy to find. but in the long term, it's going to be hard. It's hard to find. And we're going to have to use perhaps a flow net to work out the pore water pressures. So once again, we can have active or passive failure, where we go from a vertical stress to horizontal stress. We can analyze that either through a total stress or effective stress analysis, depending on our situation, whether we have undrained clay, so immediate short-term clays, or we have sands in the short term, or we're looking at the long term. So once again, the question will have to say what you're looking at: immediate, long-term, short-term clay, sands, all that type of stuff. And now I'm just going to show you the method of how we do these problems. Just a very brief summary of the method. Don't freak out too much if you don't understand it. I would recommend you watch the next video where we actually do a numerical example. So for the method, what we're going to be doing is, for a total stress analysis, we're going to set up a table with Z, sigma V, and sigma H. So we're going to have, just to conceptually show what we're doing, we're going to have our profile of soil, and we're going to have our wall, and we're going to know, so say we want to find the stress at Z. So we would put that in, call it Z1. We could then find sigma V, say this is gamma, it would be gamma Z, and that would give us the vertical stress, and then we can go from the vertical stress to the horizontal stress using either this formula or this formula, depending on whether it is an active or passive failure. So that would be for a total stress analysis. So we just need to set up that table. And we might have multiple layers, so there might be more rows to this table. And for an effective stress analysis, we have Z, sigma V, U, sigma V dash, sigma H dash, and sigma V. So we're going from Z to sigma V, same way we do there. Then we're going to find the pore water pressure. Then we're going to find the effective stress by going sigma V minus U. Then we can find sigma H dash using one of these two formulas. And then we have to go back to sigma V, the total stress. So at the end of the day, we have to find total stresses. Sorry, and this is meant to be sigma H. We want to find the total horizontal stress. And this would be a table, and we could have multiple rows. And guys, I wouldn't freak out too much about this. Just watch the next couple of videos where we'll be doing an actual example so you can see these in action. Anyway guys, hope that helps.